Dear Evil Engineer, on account of a particularly contrived origin story involving a marching band, an unrequited love, and traumatic public humiliation, I emerged as a villain who commits crimes using music. I have made a lucrative career taking contracts to provide loud, aggravating, looped music for enhanced interrogation operations. I'm interested in diversifying my business. Playing songs from children's television at captives until they beg for mercy lost its novelty long ago. Could you suggest any ways of causing physical, rather than just psychological injury through the audio medium? Yours, a musical villain.
Dear villain, I appreciate your desire to diversify your business. Providing music for psyops is good, dishonest work. But it is very war on terror circa 2001. Thankfully, there are many other ways in which you may use audio to injure, incapacitate, and discomfort your clients. The most straightforward approach to weaponizing sound is simple and effective. Make it very loud. Unlikely rumors swirled around the Russian-born French researcher Vladimir Gavreau, who was said to have invented a sonic weapon, a bust-sized whistle blown with a fan turned by aircraft engines, which produced powerful enough vibrations to kill a person 5 miles away. Far-fetched though this story was, like all the best conspiracy theories, it contained an element of legitimacy. Sound of sufficiently high amplitude can injure and even kill. Discomfort begins at 120 decibels, hearing loss at 130 decibels, physical pain and immediate hearing loss at 140 decibels, and difficulty breathing at 160 to 170 decibels. The lethal threshold is estimated at around 185 to 200 decibels. The sound cannon was first trialled in 2009 at G20 protests and has since been used for subduing public protests and in anti-piracy operations. This device, which can be mounted on a vehicle and operated by a single person, uses hundreds of transducers to create a highly concentrated sound in a narrow beam to direct at targets. The manufacturer, which asserts it is designed for long-range communications, says the device emits 2.5 kHz of sound in a 30 to 60 degree beam, although it can be adapted for 360 degree broadcasting, and has a maximum output of 162 decibels at 1 meter. People who have experienced the sound cannon describe it as nauseating, unbearable pain, and the audio equivalent to looking directly at the sun. This is a very economic, fast and clean way to incapacitate a crowd. However, there are more intriguing possibilities to explore using infrasound, sound below the frequency that can be perceived by humans, around 20 Hz. The US military has for decades investigated the potential impacts of infrasound, not only for offensive purposes, but also to understand its effect on, for instance, armed forces personnel spending time in warships with throbbing motors producing low-frequency vibrations. While sound is of course detected by the ears, infrasound appears to produce effects on the whole body. There have been reports that high-volume infrasound, such as that produced by subwoofer arrays at concerts, can cause distorted hearing, chest vibrations, difficulty breathing, and even lung collapse. Whilst a Sydney University study reported that infrasound may stimulate the vestibular system, causing a seasickness-like effect. While many of these stories are surely apocryphal, there is enough genuine concern for some health and safety organisations to have issued guidelines on exposure limits to infrasonic stimuli. there also exists a rational explanation for why infrasound could cause a variety of physical discomforts. Low frequency, long wavelength sound is more able than high frequency sound to pass through the body. This could create a volume of oscillating pressure in the body, which could in turn cause resonance. For instance, at 19 Hz at safe sound levels, people have reported their eyeballs beginning to twitch. And at higher volumes, visual distortions such as coloured lights at the periphery and blurry grey regions in the centre of their vision. Now 19 Hz is the resonant frequency of the eyeball. Sound of sufficient amplitude deforms the eyeball very slightly and pushes on the retina, activating the rods and cones by pressure rather than by light, and causing these visual distortions. The late researcher Vic Tandy suggested that infrasound could be the rational explanation for ghostly encounters, not only causing hallucinations, but nausea, pain, and moving, resonating objects. He came to this conclusion after an unsettling experience in his laboratory in which a fan was producing infrasound at 19 Hz. Different parts of the body resonate at different frequencies, depending on their materials and shape. It has been theorized that if a person's bowels can be made to resonate, control would be lost, producing the humorous effect indicated by the moniker brown note, although this has never been demonstrated under controlled conditions. In theory, if body parts are subjected to infrasound of high enough amplitude, they will stretch and shrink until they pass their elastic limit and then break. For instance, the human skull has a resonant frequency of around 9 to 12 Hz. Extremely loud infrasound at the right frequency could cause it to resonate and shatter. In reality, however, only dry, clean human skulls removed from the body have been made to resonate. Skulls, bowels, and other living body parts are filled and surrounded by squishy tissues that dampen vibrations. It is estimated that sound of 240 decibels would be necessary to cause a living human head to resonate destructively, much louder than the Tsar Bomba. I hope you will not be dispirited by my conclusion that you cannot expect human heads to explode if you only play Baby Shark loud enough. There is still plenty of opportunity to cause mischief, whether by building a sound cannon to blast do-gooder protesters or exploring the effects of 19 Hz infrasound on susceptible victims. Yours, the evil engineer.